The power rule is a shortcut to taking the derivative. If y equals x to the n, then dy dx, the derivative equals nx to the n minus 1. So for example, if we have y equals x to the fifth, so here n would equal 5, and you basically plug it in to this equation here. So then the derivative of y equals x to the fifth would just be 5x to the 5 minus 1, which equals 5x to the fourth. So say we have a negative exponent. So for example, f of x equals x to the negative fifth. Now we do the same thing as before, so n would equal negative 5, and the derivative would equal negative 5x to the negative 5 minus 1, which equals negative 5x to the negative 6. And so what if we have a fraction? So let's say u equals x to the 1/2. Same thing. The derivative would be 1/2 x to the 1/2 minus 1, which equals 1/2 x to the negative 1/2. And let's say we have a constant in front of our x. So let's say we have f of x equals negative 7x to the negative 1/2. So then the f prime of x would be same thing, bring down the negative 1/2, so it would be negative 7 times negative 1/2, which would be 7 over 2x to the negative 1/2 minus 1, which equals 7 over 2x to the negative 3 over 2. So some other things to keep in mind is that if y equals x, then dy dx is simply 1. If y equals kx, where k is a constant, then dy dx. If y equals kx, where k is a constant, then dy dx is simply k. So for example, if we have y equals 5x, then dy dx equals 5, because when you take the derivative, it's basically y equals 5x to the 1, bring down the 1, right? So then it would be 5x to the 1 minus 1, which would equal 5x to the 0, which is just 5 times 1, which is 5. And last, if y equals constant k, then dy dx equals 0. So let's try a longer problem. So if we have, say, f of x equals x to the 8 minus 3x to the negative 2 plus 2/5. So the derivative would simply be x to the 8th would be, you bring down the 8 and then we subtract 1, right? So it would be 8x to the 7th minus negative 3 times negative 2, which would be positive 6, so you plus 6x to the negative 2 minus 1, which is negative 3, and then 2/5 would just be a constant according to this rule, and that would be your answer. And that is the power rule.
Now let's talk about product rule. First, we have to remember what is product rule. So here is the formula. duv dx equals to u times the derivative of v plus v times the derivative of u. In other words, when y equals to a function fx times gx, the derivative of y would be the derivative of fx times gx plus fx times the derivative of gx. It is really important for us to remember this formula. Once you remember this formula, let's see some example. The first one, y equals to x squared times sin x. So in this case, fx would be x squared and then gx would be sin x. According to the formula, the derivative of y would equals to the derivative of x squared times sin x plus x squared times the derivative of sin x, which is 2x times sin x plus x squared times cosine x. We don't have to combine them together, so this could be the final result. Let's see another example. Y equals to e to the x times ln x. So the derivative of y would be the derivative of e to the x times ln x plus e to the x times the derivative of ln x, which is e to the x times ln x plus e to the x times 1 over x. We don't have to combine them together, but in this case, I combine them together. So each way, this one or this one could be the final result.
Well, now let's talk about quotient rule. How do you take the derivative of fx over gx? We take the denominator times the derivative of the numerator minus numerator times the derivative of the denominator over denominator squared. And one way we can remember is low d high minus high d low over low low. The low means the lower term and times the derivative of the higher term, which is the fx, and minus the higher term, the numerator fx, times the derivative of the lower term gx, and over gx squared, which is the low times low. And since quotient rule has a minus sign in the middle, it's different from the product rule. The order matters, so the low d high and high d low really helps us to remember the order of it. And now we can look at some examples. Example 1, if fx is equal to 2x plus 1 over x minus 3, then how do we find the derivative of this? So looking at the formula we have above, that we take low, which is the x minus 3, the high, derivative of the higher term, which is the derivative of the 2x plus 1, minus high, which is 2x plus 1, the low, derivative of the lower term, and over lower term squared. And after that, we take the derivative of 2x plus 1, and as we mentioned before, the power rule, we know that the derivative of 2x plus 1 is equal to 2 times x to the 0, which is 2 times 1 is equal to 2. And we do minus sign, and the derivative of minus 3 is just equal to x to the 0 power, which is 1. And we simplify our numerator, and we can get the final answer is equal to negative 7 over x minus 3 squared. And then we can look at another example. Example 2. If fx is equal to 10x, which is equal to sine x over cosine x, then how do we find the derivative of it? Well, it's the same. We take the derivative, and what we do low d high minus high d low. We take the lower term, cosine x, the high derivative of the higher term minus the low higher term derivative of the lower term and over low, which is over cosine x squared. And we know that derivative of sine x is equal to cosine x. So the first half is just equal to cosine x squared. And we know the derivative of cosine x is equal to negative sine x. So negative sine x times negative sine x, and we get positive sine x squared. So here's what we got, and we move down the cosine x, and here's what we got, and we know that cosine x squared plus sine x squared is equal to 1. So that's what we got here, 1 over cosine x squared, and we all know that 1 over cosine x squared is equal to secant x squared, and that's our final answer.